As scale model projects often do, this air cleaner took on a life of its own. Starting with a plan to simply add details to the stock AMT kit part on the left, realizing it was a bit undersized for the truck being modeled, and using a snap kit Kenworth air cleaner as the basis for the finished one on the right. Here's a look at how this air cleaner turned into a scale model in its own right. Looking at the model Mack R, with cab and hood set in place, and comparing it to the picture of the real truck, something didn't look quite right, which I realized was the air cleaner diameter, which on the model appears a little bit too small. Here's a closer look at the picture of the real truck. And a similar view of the model. The kit air cleaner isn't wrong, it just doesn't match the truck that I'm modeling. AMT's Mack R is a good representation of a mid-1970s truck, and the 13-inch diameter air cleaner it's modeled with was quite common in that era. The truck I'm modeling is the mid to late 80s, and by that time, 15-inch air cleaners were more commonly used. This picture is from a for sale ad showing a similar 15-inch air cleaner fitted to a Mack R. In 1/25th scale, a good starting point to build a model of this air cleaner is this kit, the snap-together version in 1/25th scale of the Kenworth W900 Aerodyne. Although the kit is somewhat simplified in a number of areas, it is a good overall representation of a W900 Aerodyne, as can be seen by comparing it with this picture. These kits are a good source for a variety of different parts, and for this project, the passenger side air cleaner is the correct diameter and a good match in height for the air cleaner it will be replacing. The contours at the top and bottom of the canister also match closely to the Mack R air cleaner we'll use for our prototype. One major difference is the spacing of the mounting bands, which are much closer together on the Mack than they were on the Kenworth. Canister halves are glued together and the mounting pins cut off. The projections on the top and bottom of the canister were also cut off, and the molded on mounting bands, highlighted in red, will be removed. Masking tape was wrapped around the ends of the canister to protect the molded on detail that we'll be preserving, and the majority of the molded on band was trimmed off with a chisel blade to minimize the amount of filing and sanding required. With the basic canister created, we can start adding details. We'll begin by laying out the row of bolts around the top of the canister. This plastic center finder tool was inexpensive and is accurate enough for hobby purposes. Draw one line across the middle of the canister, and use a small square to mark a second line at 90 degrees to it. The intersecting pair of lines divides the top of the canister into 4 quadrants. There are 12 bolts around the perimeter of the canister, so the next step is to divide each of the 4 quadrants into 3 equal spaces. I use the low-tech approach of measuring between the 2 lines at a measurement that would easily divide into 3, in this case 3/8 of an inch, so I made marks at the 1/8 and 1/4 inch measurements. Here, 2 of the quadrants have been marked, and these lines can be extended across the top of the canister to the other side by using the center finder tool. With a circle template, mark the bolt circle diameter around the perimeter of the canister. On my model air cleaner, the bolts are inset slightly farther than on the prototype due to the overscale thickness of the air cleaner walls. This is a compromise I can live with in 1/25th scale. Center punch each of the holes, highlighted here in red, and drill them out to receive 20 thou styrene rod. Holes are drilled, bolts are cut from styrene rod, and the hole on the top of the air cleaner is drilled out 3/16 to take styrene tube of this diameter, which fits the kit's air intake cap. The tool at the bottom is made from parts runner with 40 thou styrene spacers glued on the bottom, and is used to set each of the bolts in place as shown here as they're installed. Set each bolt in place, touch a small drop of solvent cement to it, and then push into place with the tool to set the final height. Bolts are in place. The next step is to make the round raised area, which goes on the top of the air cleaner lid, just inside the bolt circle. This starts by scoring a circle of the appropriate diameter in a piece of 40 thou styrene sheet. For this model, the circle needed to be 0.430 diameter, so the compass was set to 0.215. Drill out the 3/16 hole while the circle is still attached to the styrene sheet to make it easier to hold on to. Rough cut the circle from the styrene sheet and do initial cleanup with a fine file. For final finishing, glue the disc to the piece of styrene tube which will become the air cleaner intake pipe, and this assembly can be chucked in a drill for final shaping using sanding sticks and files. Intake cap from the Mack R kit is the part we'll be using. I like to leave the chrome on initially when cleaning up the attachment points to the molding tree, as it serves as a good filing and sanding guide. Following this step, the rest of the chrome will be removed. A parts box item, in this case air intake piping from an old Titan 90 glue bomb kit, will be used to provide the 45-degree rubber elbow that goes from the air cleaner body to the inlet piping on the engine. Initial rough sanding to shape is done, and a piece of parts runner is glued inside the thin wall pipe to give it some added strength. After cutting the parts runner off flush with the end of the pipe, the center of it is drilled out and the 1/16 brass rod pin is glued in place. Other end of the elbow gets the same treatment, and the inlet pipe on the air cleaner is made from a series of styrene tubes of various diameters telescoped together and glued in place, with the center being drilled out 1/16 to take the brass wire pin. This provides a strong connection and makes it easy to assemble the parts later, as they'll be painted in different colors. Mounting bracket starts with 20 thou by 188 wide styrene strip held in place with an elastic band around a brass tube which matches the air cleaner body diameter, in this case 21/32 of an inch. Dunking this into boiling water for a few seconds, followed by quenching in cold water, will result in the styrene strip holding the curved shape. Here you can see how nicely the finished curved piece matches the diameter of the air cleaner body, and it's been left extra long for ease of handling during fabrication. Evergreen 5/16 channel is cut to 188 long, and two 80 thou styrene pins are glued on to match the locating holes on the AMT kit cab. Sand the channel legs down to match the diameter of the curved piece, with the goal being to have the curved part contacting this channel at the two legs and in the center of the web. Once this fit is achieved, glue the curved part in place. Trimming the ends of the bracket to a consistent length is done by clamping a spacer, in this case 1/16 square brass tube, into place, and then using flush cutting pliers to trim off the extra. Mounting bracket glued in place on the air cleaner body. During test fitting, there is interference with the cowl area, so one of the mounting pins has been trimmed off shorter. The air cleaner is almost complete. There is one more small detail to add to the air cleaner body, which is this small fitting for an air line, which most likely runs inside the cab to a gauge, which will measure air cleaner restriction, indicating when it's time to service the filter element. This starts with a small styrene disc, glued on the side of the air cleaner body at the appropriate location, which is directly across from the inlet tube on the other side, and midway between the bands and the top of the air cleaner canister. Drill a 20 thou diameter hole in the end of a piece of 40 by 40 styrene strip and cut a short section of this off and glue it in place on top of the styrene disc. This represents the air fitting to which the air line will be attached. Now we'll use two sizes of brass tube, 1932 and 2132, which telescope inside each other nicely, and will be used for some more creative styrene forming, in this case bending 60 thou evergreen channel into the required shape to simulate the rubber inserts used on the air cleaner bands. The larger diameter tube provides a square shoulder against which the styrene strip can be placed to ensure everything stays nice and square during heat forming. Clamp it in place, immerse in boiling water for just a few seconds, and quench in cold water to complete the forming process. Here are the finished formed channels, along with the straps, which are made from 10 thou by 30 thou styrene strip, with small sections of strip and bolt head castings glued on to represent the ends of the strap that clamp together. Painting is necessary before final assembly, white for the air cleaner and the straps, and flat black for the intake elbow and the formed channels. Formed channels snap into place on the air cleaner body. Attach one end of each strap to the air cleaner bracket with a small drop of CA glue, and then bend the strap around, cut to final length, and secure with another drop of glue. Add a small piece of black wire to represent the air line which will run inside the cab. It's left extra long and will be inserted into a hole drilled in the firewall after final assembly. Looking a little bit more like the real truck now, an illusion also helped by addition of black paint to the frame. A small black decal with white lettering was added to the air cleaner. The decal came from this N-scale model railroad set and represents a standardized stencil used to record maintenance data on railroad freight cars. Although the N-scale decal is not an exact match for the official Mack decal, the appearance of white lettering on a black background is convincing enough in 1/25th scale. The completed air cleaner is shown here by itself. It will of course be installed later after final assembly and painting of the cab. And with the stock AMT Mack air cleaner and an out-of-the-box Kenworth Snap Aerodyne air cleaner pictured in the middle. The techniques and ideas here are of course not limited strictly to Mack R air cleaners, or just to air cleaners for that matter. They can be applied to any different type of modeling application, and if you've made it this far, thanks for watching all the way to the end. When I started out, I had no idea that a simple video presentation on an air cleaner would end up running 13 minutes in length, but it was a lot of fun along the way, doing some problem solving, and applying different techniques to reach the end goal.